isn't the chart missing stuff? For instance, it only has non-negative z-scores, like 0, 0.38, 1.04, etc. And all the probabilities are at least 1/2. Luckily, we can use symmetry to figure out what other values are. Let's do an example. What's the probability that z is greater than minus 1.2? In other words, we're trying to find the area of this guy right here. Since the standard normal distribution is symmetric when you reflect it about the y-axis, this guy here has the same area. In other words, the probability that z is greater than minus 1.2, this guy over here, is the same as the probability that z is less than 1.2. And we know how to compute the probability that z is less than 1.2 using our table, and that's 0.8849. Let's now compute the probability that z is less than minus 1.2. In other words, we want to compute this area. Here, the idea is that this area here is this guy, everything minus this stuff over here. Well, in other words, the probability that z is less than minus 1.2 is equal to 1 minus the probability that z is greater than minus 1.2. And we know what the probability that z is greater than minus 1.2 is because we computed that in the previous slide. That's 0.8849, and so our answer is 1 minus 0.8849, which is 0.1151.